Let's do a little experiment by going back to the if structure, adding a new variable y to the mix, and within every if and else if, let's increment the value of y with the incremental operator. Now at the end, let's output the value of y along with everything else and see what we get. So each time the loop iterates, we're resetting the value of y to 0. And each time one of the if or else if scenarios triggers, we add 1 to the value of y, right? We're incrementing y. Well, considering what we know about how the if structure works, the output here makes total sense. In an if setup, only one of the blocks in here will trigger, the if or one of the else ifs, or if you have one, the else. Thus, we're only incrementing y once each time the loop goes around, and hence why we're getting 1 at the output each time. Now let's do the same thing with the switch statement, leaving out the break statements so that we can really see what the switch statement is all about. Now the switch statement gives us quite a different output for y, doesn't it? The first time the loop goes around, y is 6. The next time, y is 5, then 4, and so on until y ends up at 2. Also, if you look closely, you'll see that the statements about x are not correct either, are they? So what's going on here? Well, here's the deal. Unlike the if structure, where you enter the code block that evaluates as true and then automatically exit the entire if structure, the switch evaluation only marks the entry point. There is no automatic exit point. Once one of your cases evaluates to a true, you enter the code blocks and continue to run all of the following code blocks until you reach either the end of the cases, including the default if you have one, or you manually exit the switch with a break statement. Okay? If x is 1, we enter the code block at case 1 and perform all of the following cases as well until we reach the end or we hit a break. If the value of x is 2, we skip 1 and enter at 2 and continue on down from there, all the way to the end. If the value of x is 6, even though that's not actually possible in our scenario, we still hit the default and get at least 1 increment of y. So when we run our loop, we can start to see why y is outputting this way. Let's go quickly through it. First iteration, y is 0, x is 1. Switch on x. Case 1, we enter the code block. Set the status to is less than 3 and increment y to 1. We then keep going down. Overwrite the status to is less than 3 and increment y to 2. Next, overwrite the status to is equal to 3 and increment y to 3. Next, overwrite status to is greater than 3 and increment y to 4. Next, overwrite status to is greater than 3 and increment y to 5. Next, the default, set status to is out of bounds and increment y to 6. Now we're out of the switch. Now, x was 1. Status has been overwritten a bunch of times to now is out of bounds. And y is 6. And around we go for another iteration of the loop. Reset the value of y to 0, and this time x is 2. Case 1, is x 1? No, it's 2, so false, we skip it. Case 2, true, in we go. Set status is less than 3. And increment y to 1. Next, overwrite status to is equal to 3. And increment y to 2. Next, blah, 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 all the way down. And when we're out of the switch, now x was 2, status was is out of bounds, and y this time, because we skipped 1, y was 5. And around we go again with x being 3, and on until x is greater than 5, and we finally exit the loop. At each iteration of the loop, we enter into the code blocks one case further down the block. and hence why we're losing 1 from the value of y each time x increments by 1. Do you see the pattern here? And more importantly, do you see why it's really different from if? If can't do this. Hey, this is Scotty from CodePanic, and this was just a tiny snippet of my web application masterclass series. If you're interested in increasing your skill set, staying ahead of the coming AI wave, and learning to build web-based applications, check out my web application masterclass series over at codepanic.tv. I know you're going to like what you see.